Yeah, in this question, we are told that an aeroplane moved from this point. I just represented because I know by now you can represent this thing. Moved at this point, and it flew due south. We need to be careful with this question. Now, that the question says due south does not mean that the airplane has gotten to the southern hemisphere. The airplane may still be in the northern hemisphere, it may be on the equator, and it could be below, which is the southern hemisphere. But because they have said due south, I may just put something here on the southern hemisphere. When I'm done, my calculation will show if actually the airplane has moved to the southern hemisphere. They said due south, so it just went due south. So let's come over here and create something so that we can just have a good diagram. Let's call this beta. I'm looking for beta. Okay, let me call it beta. So I have this, and I have this. So it moved from here and moved to this place. So let's call this the first position. Let's call this the second position. So we can see that the airplane moved on the same longitude. So I'm going to move this to the center of the equator because it's on a great circle. We moved on a great circle. So this is my capital R. This is my capital R on a great circle. Let's call this theta. This is my distance. All right. And they gave us the speed and the time. They gave us the speed and the time, so you know that we can calculate the distance from there. So because the speed equals distance over time. So looking at this, I can solve for distance by saying speed times time. And when you do that, the speed given to us here is 8:50. Then the time given is 4 hours. When you do this, calculate it, you're going to have 3,400 kilometers, which is important to us, distance, because we need it in this place. So if I get the angular difference, then we'll be able to tell if it has actually moved to the southern, or maybe still in the northern, or is exactly on the equator. Let's get started. So the formula for this distance will be the formula we have been using, which is theta over 360 2 pi capital R. And that's what it's going to be. Let's try and break everything down in this case. So let's look for this. This distance is now 3,400, which is equal to what I don't know, theta over 360 times 2 times 22 over 7 times 6,400, assuming is the radius of the Earth. So my theta in this case, when you do all the cross multiplication, that will give you 3,400 times 360 times 7 over 2 times 2 times 6,400. When you calculate theta, you will get 30 to 2SF. 2SF, you give it 30. All right, that is my theta, and that is not what I'm looking for. I'm actually looking for this position. Now, please pay attention. I want to explain something here. This 21 you have here, you know, I told you the other time I was solving, something was on the equator and it moved here. I said it was 90. If it was here too and it moved to the north, it will be 90. So a point from this place to this place is 90. Okay, so that means that from here to here will give me angle 21. See this, this is 0. So from this place to this place is 21. So something is here. If it moves and it is 21, it will be here exactly. So if after calculating I got 21 here, it means that point is on the equator. If after calculating my theta, if I got 21 here, it means it just moved from 21. Subtract 21 from 21, we're going to have 0. So that means it's exactly on the equator. But look at this case. It moved from here, it got to 21, it got beyond 21. So that means it's now in the southern. So because it's now in the southern, look at it, it's more than this. That simply means that I'm supposed to add this and this to get this theta. I'm supposed to add this and this to get the theta, which means it's supposed to be beta plus 21 to give me 30 degrees. Do you understand what I'm saying? When I add two numbers, it means they are on different side of the pole. When I subtract, it means they are on the same side of the pole. So in this case, the angular difference is 30, which is more than one of the points given to me. That simply means that they are on different side of the pole. So to get my beta now, I'll simply subtract. And when I subtract 30, subtract 21 from it, you will get 9 degrees. So the beta is now 9 degrees towards the south. 9 degrees towards the south. If the value gotten for theta is something like 15, that means they are on the same side. Then it will be 21 minus beta to give me the 15. But I'm using plus because the value here for theta is more than one of the points given to me. So please note that. If you didn't get that, rewind the video over and over till you get it. In this question, we are told that there are 2 points, A and B, and they are on the same latitude, 70 degrees north. So this is the place where, this is the longitude where the B is, and this is the longitude where the A is. 118, and we also have 62 over there. Now, the question is asking us two things. The first one is, we should find the distance from A to B along a great circle. Along a great circle. That's the first one. Then the B part is saying we should also find the distance between them along the latitude. So let me show you the meaning of that word, great circle. You know, we want to find the distance between this and this along great circle. It means I want to connect this to a great circle. You know, great circles are everywhere. So if I draw a great circle from here and it goes like that and it joins somewhere here, I want to find the distance between these. So say there's a great circle somewhere, you know, that connects this. Okay, let me even draw it like this. That connects it like that and go to the back and something like that. So I want to find this distance here along the great circle. So let me use another color to make it more fun. So we have this here. I'm looking for this distance. And they said along great circle. So one thing you want to do here is to trace this to the center of the great circle. Center of the great circle. So this is going to be capital R, this is capital R, and this is going to be the theta. This is theta. So what formula are we going to use here? If you go back to my earlier video, you see I gave you different formulas for different purposes. So when you have 2 points on the same latitude, you can find the distance between them along great circle. You can find the distance between them along small circle, like along latitude. You can also find the distance, the distance of the chord between them. You can also find that. So in this case, they are only asking us to find the distance along the great circle, and that is where you're going to be using this formula. So the distance is 2 arcsine sine alpha over 2 cos given latitude theta over 360. This is how we will find this theta in this case. To find the angular difference in this case, where you have 2 points on the same latitude and you're looking for the distance between them along great circle, this is the formula that will help you to find the theta. Then you now complete the formula for 2 pi r. You know the formula is theta over 360, 2 pi r, because they are on the same great circle now. On the same great circle. So this is my theta right here, and this is my 2 pi r. As simple as that. If you have a problem with that, please go to the previous video I did on latitude and longitude. It will be very, very clear. So what we need to do is to substitute the values we have, and that will help us to be able to get any other thing that we need in this place. So the question may be, what's my B? My beta here is this value 70. Then somebody may ask, what's my alpha? my alpha is the angular difference of the latitude. That's why I decided to use different symbols for angular difference between the latitude and angular difference between the great circle. So I'm looking for this now, but I need this here. So if I come over here and I trace this to this, and I trace this to this, the angle I get here, the alpha, this alpha is this alpha here. And we all know how to get this alpha. So this alpha you have over here is this plus this, because they are on different sides of the pole. So my alpha in this case, my alpha is 62 plus 118 degrees, which will give me 180 degrees. And I told you that is the highest value you can have for the alpha. When I started, I said that. Then I said my beta in this case is my 70 degrees. And that's about all we need in this place to be able to solve this. Let's use our regular 40,000 here for this. And let's substitute the value and see what we're going to have. So if we do that, we're going to have my distance now to be equal to, I'm checking the camera, to be equal to 2 arc sine, that's my alpha over 2. Let's just do alpha over 2. That will be 180 divided by 2. Alpha 180 divided by 2. That's my 90. Then I have cos 70 over 360. Then this whole thing up here is representing my theta. Then times 2. Okay, we said we should use 40,000 to make the workings easier. Let me just clean this and put 40,000. 40,000. Let's keep working. If I do this, I'll have 2 arc sine. This is 1. Sine 90 is 1. So let's look for cos 70. Get my calculator and look for cos 70. Cos 70 is 0.3420. Then over 360. And this times 40000. Let's work this out. Let's see what it will give us. You have 2 times arc sine of 0.342. That gives us 40. So this is 40 up here. 40 over 360 times 40,000. So let's see what that will give us when we calculate it. And that will give us 440 kilometer. And that is it. That is it. This, all you need is to know what your alpha is and to know what your beta is. And that's all. Substitute in the formula and you are good to go. Let's go to the B part of this question. The B part is asking us to find the distance between this along the latitude. Along the latitude, we just used our normal formula for along the latitude, which is alpha over 360 2 pi small r, which is capital R cos given latitude. And we just did this. We saw it's 180 over 360. Then we said we want to use 40,000 here. Then cos given latitude, cos 70 degrees. And that will give us half of 40,000 cos given latitude, which is 0.3420. This will cut this and give us 20,000 times 0.3420 and the distance there will be 6840 kilometers. So that's the distance. If I want to calculate the distance along the latitude from A to B, which is this place, that's what's going to be. And that's why, if you check my previous video and when you read textbooks, they will tell you that when you have 2 points on the same latitude and you're looking for the shortest distance between them, the distance along the great circle is always the shorter distance. 2 points on the same latitude, you're looking for the shorter distance or the shortest distance. The distance along the great circle is the shortest distance between them. And you can see that this is the distance along the small circle, that's pi of latitude. The previous one we did was the distance along great circle, and that appears to be the shorter distance. Thank you for viewing.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.